A single powerful radio pulse shot toward a distant star cluster in 1974. This was the Arecibo message, humanity's first deliberate shout into the cosmic void. It marked the birth of an audacious endeavor known as METI, Messaging Extraterrestrial Intelligence. This is not about passively listening for signals the way SETI does. This is about actively calling out, announcing our presence to the universe. You will discover the full story behind our modern cosmic calls, from the brave teams who send them to the fierce debate over whether we should. We will uncover the secrets encoded in these interstellar messages and examine the incredible technology that makes them possible. But this journey raises profound questions. What if someone is actually listening, and what might they think of our attempts to communicate? What responsibility do we bear when we speak for an entire planet? Do you believe we are ready for an answer? This shift from listening to shouting is not merely a change in technique. It is a profound philosophical leap. For decades, the dominant approach was SETI, the search for extraterrestrial intelligence. This is a patient, almost meditative practice. We point our antennas at the stars and we listen, hoping to catch a whisper, a signal, a sign that we are not alone. It is a cosmic version of eavesdropping, waiting for someone else to start the conversation. METI, Messaging Extraterrestrial Intelligence, throws that patience out the airlock. It is the decision to stand up in a silent, darkened theater and shout hello. This is an active, intentional declaration of our existence. It is the difference between hoping to find a message in a bottle and building a lighthouse on the shore, its beam sweeping across the ocean with a deliberate, repeating call. This philosophical shift did not happen in a vacuum. It was shaped by decades of silence from the cosmos and a growing human impatience. Even the great Carl Sagan, a champion of cosmic connection, embodied this deep-seated tension. Sagan was famously cautious, one of the leading voices warning against sending messages without international consensus. He feared what an advanced and potentially predatory civilization might do if it discovered a new, vulnerable world. Yet, it was this same Carl Sagan who helped create the most beautiful and ambitious calling cards humanity has ever sent, the golden records aboard the Voyager probes. These are not radio signals but physical artifacts, time capsules carrying the sounds and images of Earth out into the galaxy. This contradiction reveals a core human conflict, the struggle between the instinct for self-preservation and the burning, existential urge to connect. That urge is what truly fuels METI. It is the same impulse that makes a child wave from a car window, hoping for a wave back from a stranger. It is the desire to break the crushing silence of the universe and affirm, in some tangible way, that we matter. We are here, we are thinking, we are feeling, and we want to know if anyone else is out there. This is not just scientific inquiry, it is a form of cosmic identity. By speaking, we define ourselves. We declare that humanity has reached a point in its development where we can not only ponder the stars, but attempt to converse with them. The question is no longer just are we alone, but do we have the courage to introduce ourselves and risk an answer? That profound urge to connect finally found its voice in a 3-minute burst of radio waves. On a crisp November day in 1974, humanity composed its first deliberate greeting card to the cosmos. The newly upgraded Arecibo radio telescope in Puerto Rico, then the most powerful instrument of its kind, was aimed at a dazzling target, a globular star cluster called M13, a city of stars some 25,000 light-years away. The event was largely ceremonial, a demonstration of the telescope's new capabilities, but its implications were eternal. The team behind this historic transmission was a gathering of scientific giants. Frank Drake, the pioneer who had already formulated his famous equation for estimating intelligent civilizations, worked alongside a young Carl Sagan, whose poetic vision of cosmic connection was tempered by his own cautious warnings. Together, they crafted a message meant to be deciphered by a mind utterly alien to our own. So, what did they say? The message was a string of 1,679 binary digits, ones and zeros. This number was chosen carefully because it is the product of two prime numbers, 23 and 73. The assumption was that any civilization advanced enough to detect the signal would recognize this mathematical pattern. They would then arrange the string into a grid 23 squares wide and 73 squares tall, revealing a series of pictograms. The first section established a universal language, the numbers from 1 to 10 in binary code. Then it listed the atomic numbers for the fundamental building blocks of life: hydrogen, carbon, nitrogen, oxygen, and phosphorus. Next came the elegant double helix of DNA, showing its structure and the number of nucleotides in the human genome. Below that, a simple schematic of a human stick figure appeared, showing our average height and our population of the time, over 4 billion. The message then depicted our solar system, highlighting Earth's position as the third planet from the Sun, the one from which the signal originated. Finally, it showed a crude but recognizable drawing of the Arecibo telescope itself, with its massive dish and the diameter of its antenna. This entire cosmic postcard was beamed into the void with a power of 20 trillion watts, a focused shout of unimaginable intensity. Of course, the team knew this was a message for the far future. M13 is so distant that the signal will take 25,000 years just to arrive. Any potential reply would not reach us for 50,000 years. The Arecibo message was never really about expecting an answer. It was a symbolic act, a declaration of existence. It was humanity, a young and curious species, standing on its planetary shore and tossing a bottle into the galactic ocean. That single transmission became the grandfather of all modern METI attempts, proving that the technology existed and that the will to use it was there. It set a precedent, a template for how we might speak to the stars, but it also left a crucial question hanging in the air. If we are going to keep shouting, what should we say next and who gets to decide? 25 years after that first symbolic shout, a small team decided it was time to make the conversation more personal. The year was 1999, and a project called Cosmic Call transformed METI from a scientific demonstration into a global, almost intimate endeavor. This was not the work of a single government agency, but a bold private venture organized by a company called Team Encounter and led by passionate scientists like Alexander Zaitsev and Richard Brostad. They turned the massive Evpatoria planetary radar in Ukraine, a sister to the great Arecibo dish, into a cosmic megaphone. This time, the messages were not just for a distant star cluster tens of thousands of years in the future. They were aimed at four specific, sun-like stars a mere 50 to 70 light-years away, close enough in cosmic terms that a reply could theoretically reach us within a human lifetime. So what did they send into the neighborhood? The content was profoundly different from the Arecibo message scientific primer. At its heart was something called the Book of Life. This was a digital collection of thousands of personal messages, drawings, and even photographs submitted by ordinary people from around the world. Imagine a child's drawing of their family, a poet's verse about love, or a simple greeting in 100 different languages, all encoded into ones and zeros and beamed toward other suns. This human mosaic was bundled with scientific data, creating a time capsule not just of our biology and technology, but of our hopes, our art, and our individual voices. Cosmic Call was a monumental first. It was the first fully fledged civilian effort to message the stars, funded not by a government but by the collective curiosity of the public. It fundamentally changed the question from what a committee of scientists should say to what all of humanity might want to say. It democratized the cosmic conversation, turning it from a lecture into a chorus of 1,000 different songs. This act of collective expression sent a powerful new kind of signal into the universe, one that said we are not just a planet of intelligent life, but a planet of individuals. 2 years after that global chorus, the same deep space antenna in Evpatoria aimed its dish skyward once more, but this time with a new voice. The Teenage Message Project in 2001 was not just another transmission, it was a lesson plan for the stars orchestrated by the relentless Alexander Zaitsev. This project had a unique educational soul, designed not only to speak to extraterrestrials but to involve the next generation of Earthlings in the process. Teenagers from around the world were brought into the creation of the message, ensuring that the signal carried the perspective of youth, the very future of humanity. The message itself was a sophisticated interstellar multimedia presentation, structured in 3 distinct parts, each with a different purpose. First, it included a cosmic concert, the very first time music was deliberately sent to another star system. The instrument chosen was the theremin, an electronic device played without physical contact, its ethereal, otherworldly wails perfectly capturing the mystery of space. Following this musical introduction came a digital soundscape of Earth. Imagine the roar of ocean waves, the gentle patter of rain, the complex songs of birds, and even the sounds of human technology, all converted into data. This was an audio postcard of our living world. The final section grounded the message in scientific data, providing a coherent explanation of the sounds and music, detailing the principles of physics and chemistry that underpin our reality. This 3-part structure was a holistic portrait of humanity, blending our art, our environment, and our science into one package. The signal was directed toward 6 carefully chosen sun-like stars, all within a 70 light-year radius. The ultimate goal of the Teenage Message was to present a vision of humanity that was not ancient or fearful, but youthful, curious, and full of potential. It asked a silent question of the cosmos: what would another civilization think of a species that sends its music, its world sounds, and its knowledge, all curated by its children? This was a bid to be seen not as a threat, but as a promising student in the vast galactic community, a species still learning, still growing, and eager to share its first fumbling discoveries. The digital age finally found its voice in the cosmic conversation. In 2008, a social media platform called Bebo partnered with scientists and the Ukrainian Space Agency to launch a message from Earth. This project fully embraced the emerging power of online connectivity, collecting 501 text messages and digital images from its global user base. People from all walks of life submitted their thoughts, from simple greetings like "Hello" from Sarah in London to philosophical musings, digital artwork, and even pictures of favorite meals. This vast, eclectic digital scrapbook was then carefully encoded into a radio signal and transmitted by the same Evpatoria radar that had sent the earlier messages. Its target was not just any star, but a specific point of fascination, Gliese 581c, a distant world then considered one of the first potentially habitable exoplanets ever discovered. The choice was deeply symbolic, aiming our collective voice directly at a place that might actually be able to listen. This event marked a definitive turning point for messaging extraterrestrial intelligence. It was no longer the sole domain of astronomers and physicists. With a message from Earth, METI became populist and accessible, a product of the global village. Anyone with an internet connection could contribute to our planetary greeting card. This democratization was thrilling, a testament to our interconnected world, but it also cast a new and uncomfortable spotlight on an old ethical dilemma. When we beam a signal into the void, we are not just sending data, we are sending a representation of our entire species. So who gets to decide what that representation looks like? The curated messages from scientists presented a unified, logical picture of humanity. This new crowd-sourced approach was wonderfully messy, chaotic, and beautifully human, a cacophony of our collective consciousness. But it also meant that our official introduction to any listening civilization could include a picture of someone's cat, a political rant, or a teenage love poem. This project forced us to confront a profound responsibility. Is speaking for Earth a task for experts, or is it a right belonging to every single person on the planet? The signal is now racing toward its destination, carrying the unfiltered, contradictory, and utterly authentic voice of a world trying to say hello for the very first time. The chaotic democracy of cosmic messaging soon demanded a more permanent voice. In June 2013, a new project called Lone Signal aimed to transform our interstellar greetings from a one-time postcard into a continuous, living conversation. This was another crowd-funded, crowdsourced effort, but with a crucial technological twist. Instead of a single, powerful transmission, Lone Signal planned to broadcast a non-stop stream of messages for as long as funding and public interest allowed. They took over the Jamesburg Earth Station in California, a historic satellite communications dish nestled in the Carmel Valley, and pointed it toward the heavens with a new purpose. The project's core was a clever dual message system designed to be both scientifically coherent and deeply human. The first part was a continuous beacon, a repeating stream of fundamental scientific data. This beacon was meant to be the universal handshake, establishing a basic language of mathematics and physics that any advanced civilization could presumably decode. It was the logical framework upon which everything else was built. Interleaved with this scientific beacon were the text messages submitted by thousands of people from across the globe. For a small donation, anyone could compose their own personal thought and have it beamed into the cosmos. Imagine a continuous river of ones and zeros flowing skyward, carrying within it a child's question about the stars, a lover's promise, a poet's reflection on existence, all riding on the back of a relentless scientific pulse. The chosen target for this ongoing broadcast was a specific, promising star known as Gliese 526, a red dwarf located just over 17 light-years away. Astronomers identified it as a prime candidate for potentially hosting habitable worlds, making it one of our closest and most interesting neighbors. This was no symbolic shot into the distant void. This was a deliberate attempt to start a conversation with a specific cosmic address, a conversation that could, in theory, see a reply within 34 years. Yet, despite its ambitious vision and initial public excitement, Lone Signal faced a harsh reality. The project encountered significant financial challenges and was ultimately suspended after only a few months of operation. Its story highlights a fundamental obstacle for modern METI efforts: the sheer difficulty of sustaining such a long-term, resource-intensive endeavor. Building a cosmic lighthouse is one thing, but keeping its light burning for decades or even centuries is a challenge that goes far beyond technology. It tests our collective patience, our wallet, and our enduring will to be heard in the great and silent dark. The WOW signal remains one of astronomy's greatest unsolved mysteries. For 35 years, that single burst of data, so powerful that a scientist scrawled "wow!" on the printout, haunted the search for extraterrestrial intelligence. It was a tantalizing, one-time event that was never heard again. Then, in 2012, a group decided it was finally time to answer. To mark the 35th anniversary of the original detection, a team of astronomers and artists organized the WOW Reply project. They gathered over 10,000 text messages and video submissions from the public, using the social media platform Twitter as their digital town square. This collection of human thoughts was then converted into a digital signal and transmitted by the most iconic instrument in the field, the Arecibo Observatory. The target was not a random star, but the precise area in the constellation Sagittarius where the original WOW signal was thought to have originated. It was a cosmic callback, a deliberate response to a decades-old hello. The scientific community, however, met this romantic gesture with deep skepticism. The fundamental problem was that the original WOW signal was detected by a telescope that could only listen, not pinpoint its source with any real accuracy. The origin point is a fuzzy patch of sky, not a specific stellar address. Sending a reply there was like shouting back into a canyon long after the echo has faded, hoping your voice reaches the one person who might have called out. Many researchers criticized the effort as scientifically unserious, a publicity stunt that ignored the basic principles of radio astronomy. It was, they argued, a message sent to a mystery with no guarantee that anyone or anything was even there to receive it. This controversy highlights a core tension in modern attempts to contact alien life. Is the symbolic act of reaching out, of answering a potential call, valuable in its own right, even if the odds of success are astronomically low? Or does such an effort risk muddying the scientific waters, turning a serious search into a series of hopeful but misguided shouts into the wind? The wow reply did not solve the mystery, but it did force us to confront a difficult question about our own methods. When we hear a whisper from the cosmos, how do we decide when and how to shout back? Music itself became the next language to cross the interstellar void. In 2018, a groundbreaking project emerged not from a university lab but from a festival. Sonar Calling GJ273b was a collaboration between the Sonar Music Festival in Barcelona, the Institute of Space Studies of Catalonia, and a team of METI scientists. This fusion of art and science aimed its message at one of our most promising known neighbors, an exoplanet called GJ273b, orbiting the red dwarf star Lytton star. This world sits squarely within its star's habitable zone, a region where temperatures could allow for liquid water and perhaps for life. The message was not a simple shout into the dark, it was a carefully crafted lesson plan for the cosmos. The transmission began with what the creators called a tutorial, a primer designed to establish a common language. It explained the fundamental concepts of mathematics and time, using simple radio wave pulses to illustrate counting and the passing of seconds. This tutorial was the cosmic handshake, the universal grammar meant to pave the way for what came next. Following this scientific introduction came the real heart of the message, 33 unique musical compositions. Renowned electronic artists like Ortega and Jean Mitchell-Jar were commissioned to create short pieces specifically for this purpose. These were not simply songs from Earth's pop charts. They were sonic artworks designed to be beamed to another world, each one a brief, abstract burst of human creativity. To encode this complex package of tutorial and music, the team employed a new and more sophisticated language, the Messaging Extraterrestrial Intelligence Protocol, or MESS. This system was a major upgrade from the simple binary code of the Arecibo message. MESS uses a repeating header that acts like a key, announcing how the message is structured so a receiving intelligence can piece the information together correctly. It is designed to be more robust and easier to decode, a clearer envelope for our interstellar mail. The Sonar project represents a significant evolution in our approach. It moves beyond simply stating we are here to attempting to convey what it feels like to be here. By sending music, we are sharing the abstract, emotional, and non-logical part of our existence. We are sending the rhythm of our culture, the melody of our minds. This project asks a profound question of any civilization that might one day hear its signal. What would another intelligence make of our math, followed immediately by our music? Would they see the connection between the logical structures of the universe and the creative expressions they inspire? We are offering them not just our knowledge, but our soul, crafting a message for a mind that might not see, hear, or think like ours is the ultimate creative puzzle. It forces us to abandon every assumption about communication and search for concepts so fundamental they must be true everywhere in the cosmos. This quest for a universal language begins not with words, but with the bedrock of reality itself, mathematics and physics. The hope is that the laws governing atoms and stars are the same in any corner of the galaxy, providing a shared dictionary for our first halting introduction. Prime numbers became our first interstellar handshake. These are numbers divisible only by themselves and one, like 2, 3, 5, and 7. They are the indivisible building blocks of mathematics, and their pattern is not a human invention but a universal discovery. The Arecibo message leveraged this by sending 1,679 binary digits, a number that is the product of two primes, 23 and 73. The assumption was that any civilization advanced enough to detect the signal would recognize this numerical pattern as artificial. They would then arrange the string into a grid 23 squares wide and 73 squares tall, unlocking the pictograms hidden within. This was our way of saying, this message has structure, and here is the key. Another powerful mathematical concept is the Fibonacci sequence, where each number is the sum of the two preceding it, creating a spiral pattern seen in galaxies, hurricanes, and sunflower seeds. By sending this sequence, we are pointing to a pattern that appears both in pure math and in the natural world around us, a bridge between abstract thought and physical reality. From there, we build upward using this mathematical language to describe the physical universe. We list the atomic numbers of the elements essential for life: hydrogen, carbon, nitrogen, oxygen, and phosphorus. We depict the elegant double helix of DNA, the molecule that carries the blueprint for every living thing on our planet. These are not human ideas, they are the fundamental ingredients of a living world, facts we hope are universal. But how do you package these concepts into a radio wave? The earliest method used in the Arecibo message was starkly simple binary code, a series of on and off pulses, ones and zeros, that could be arranged into a bitmap image. It was a cosmic fax, a picture made from pure radio energy. More recent efforts, like the MESS protocol used for the Sonar Music project, are far more sophisticated. This system acts like a complete instruction manual for the message. It begins with a repeating header, a specific sequence that announces, this is the start of a structured communication. It then provides the rules for decoding the rest of the signal, explaining how to interpret the subsequent data as numbers, images, or even sound. Think of it as sending a letter where the first page carefully explains the alphabet and grammar used to write the pages that follow. This layered approach attempts to solve the problem of context, ensuring that our description of a human figure or a musical note isn't mistaken for random noise. The true test of any language, however, is whether it can convey feeling, not just fact. This is the monumental challenge of sending art. How do you encode the haunting wail of a there min or the complex rhythm of an electronic composition into a signal that an alien intelligence could not only decode but perhaps even feel? We are trying to transmit the ineffable, the parts of our existence that have no atomic number or mathematical formula. We are betting that the universe, for all its physical laws, also has room for beauty, and that a mind capable of understanding the structure of an atom might also be curious about the structure of a song. In the end, every one of these messages is a leap of faith, a bottle tossed into the ocean with a note written in what we hope is a universal tongue, carrying both our knowledge and our dreams. But the choice of what to say is only half the battle. The other, equally crucial decision is how we send it. The medium we choose to carry our message across the light years fundamentally shapes the conversation, imposing its own strengths, limitations, and even its own meaning. For decades, our primary cosmic megaphone has been the radio wave. The transmissions from Arecibo and Evpatoria were titanic bursts of focused energy, leveraging the quiet of the universe in the radio spectrum to make our shouts as clear as possible. Radio's great advantage is its proven, practical nature. We have the technology, the massive dishes, and a deep understanding of how these waves travel through the interstellar medium. A radio message is like sending a powerful, resonant bell tone through a silent hall, a tone that can be detected across staggering distances, yet radio has significant drawbacks. The signals, for all their power, still disperse and weaken over light years. They also move at the universal speed limit, the speed of light, making any dialogue with even the closest stars a multi-generational affair. And perhaps most frustratingly, our own planet has become a cacophony of radio and television leakage, a noisy background that might make a deliberate, powerful signal difficult for another civilization to distinguish from our accidental static. This has led scientists to explore a more focused and potentially more powerful alternative: laser communication. Imagine replacing that ringing bell with a brilliant, razor-thin laser beam. This is the promise of optical METI. A powerful laser could, in theory, transmit a signal that is millions of times brighter than an equivalent radio wave for the brief instant it flashes past a target star system. It offers incredible bandwidth, meaning we could send vast libraries of information, high-definition images, or complex scientific data in a single, concentrated pulse. The laser's narrow beam avoids the problem of dispersion, carrying its energy much farther with less degradation. However, this pinpoint precision is also its greatest weakness. Aiming a laser beam perfectly at a star system dozens of light years away is an engineering challenge of almost unimaginable accuracy. A miscalculation of a fraction of a degree would mean the entire message misses its intended target completely, shooting off into the empty void between stars. It is the ultimate cosmic sniper shot, requiring perfect aim and perfect timing. Looking even further into the future, some visionaries propose we abandon energy waves altogether and send a physical object. The Breakthrough Starshot initiative embodies this radical idea. Its goal is to develop a fleet of tiny, wafer-thin probes, each attached to a light sail, and propel them toward the Alpha Centauri star system using a powerful ground-based laser. These nanocraft would travel at a significant fraction of the speed of light, reaching our nearest stellar neighbors in just over 20 years. The appeal is profound. A probe is a permanent artifact. It does not fade away like a radio signal. It could carry physical samples, complex machinery, or detailed engravings, delivering a rich, tangible piece of our civilization directly to another world. But the challenges are equally monumental. The technology for such a journey is still in its infancy. The probes would be vulnerable to interstellar dust and radiation, and even if they survived, they would scream past their target at incredible speeds, offering only a fleeting moment for any potential discovery. They are more like interstellar message in a bottle missions than a two-way conversation. Beyond lasers and probes, scientists have theorized about even more exotic messengers, such as neutrino beams. Neutrinos are ghostly subatomic particles that barely interact with normal matter. They can pass cleanly through entire planets and stars without being absorbed. A neutrino message would be the ultimate cosmic broadcast, able to penetrate regions of space that would block radio waves or light. But this very property makes them nearly impossible to work with. Generating a focused, detectable beam of neutrinos requires technology far beyond our current capabilities, and building a receiver large enough to catch such a signal would be a project of planetary scale. For now, it remains a fascinating thought experiment, a reminder that our choice of medium is ultimately a reflection of our own technological adolescence. Each method, from the reliable radio wave to the speculative neutrino, represents a different bet on the future, a different guess about how best to be heard in a galaxy that has so far offered only silence. Choosing the right cosmic address for our messages is a science in itself. We cannot simply shout into a random part of the sky and hope for the best. Scientists must make deliberate, calculated choices, aiming our most powerful transmissions at the stars most likely to host listeners. This targeting process relies on a carefully crafted set of criteria, a cosmic checklist for finding a promising pen pal. The ideal candidate is a star that resembles our own sun, a stable, middle-aged G-type star that has burned steadily for billions of years, providing the long-term stability thought necessary for complex life to evolve. But our Sun is not the only model. The search also focuses on smaller, cooler K-type stars, which are far more common and often host rocky planets within their habitable zones, that Goldilocks region where temperatures are just right for liquid water to exist. To systemize this search, astronomers developed a specialized catalog known as the HabCat, or the Catalog of Habitable Stellar Systems. This was not just a list of every star in the neighborhood. It was a curated selection, a short list of the most promising targets within 100 parsecs, about 326 light-years of Earth. Each star in the HabCat was vetted for its stability, its age, and its potential to host Earth-like planets, making it the ultimate guidebook for modern METI efforts. This is why so many of our messages have familiar names. Stars like Tau Ceti, a Sun-like star just 12 light-years away, have been a favorite target for decades. Its relative closeness and stability make it a prime candidate for any civilization looking back at us. Then there is the Gliese 581 system, a red dwarf that captured global attention for hosting some of the first known potentially habitable exoplanets. Our messages aimed there were not just shots in the dark, they were deliberate attempts to make contact with specific worlds. And of course, Lytton Star, another red dwarf, was the destination for the Sonar Music Project, chosen because it hosts a known planet, GJ273b, squarely within its habitable zone. We are no longer broadcasting to abstract points of light. We are sending mail to specific planetary systems. But aiming a message at a star is not like pointing a flashlight at a wall. The precision required is almost beyond comprehension. A star dozens of light-years away is an unimaginably small target in the vastness of space. Scientists must account for the star's motion through the galaxy, calculating not where it is now, but where it will be when our signal finally arrives years or decades in the future. They must also compensate for the subtle gravitational pull of other stars and the precise timing of Earth's own rotation and orbit. It is a celestial game of billiards played on a table light-years across, requiring us to bank our shot off the moving cues of planetary physics just to have a chance of hitting the pocket. And even if our aim is perfect, the message itself is a fragile thing. Over its immense journey, the signal spreads out and weakens, its once powerful shout becoming a faint whisper by the time it washes over any distant world. This incredible effort, this pinpoint accuracy across such staggering distances, raises a humbling thought. Every time we send one of these messages, we are performing a technological miracle, a demonstration of our growing understanding of the cosmos. But we are also making a profound assumption that someone out there is using the same tools, listening on the same frequencies, and looking back at us with the same hope. We are aiming for a destination we cannot see, hoping to start a conversation with a voice we have never heard. These cosmic calls require a physical voice of almost unimaginable power. The instruments that shout our messages into the galaxy are not simple radio antennas. They are planetary-scale megaphones. The most famous of these was the Arecibo Observatory in Puerto Rico, a colossal dish 1,000 feet wide, carved into a natural limestone sinkhole. This was the instrument that sent the very first Arecibo message, a testament to its sheer capability. But Arecibo was not alone. The Evpatoria planetary radar in Ukraine served as the other great workhorse for modern METI, sending the cosmic call, the teen-age message, and the later transmissions. These facilities are not just telescopes for listening, they are powerful radars engineered to do the opposite, to project. So how do they turn a whisper of data into a shout that can cross light years? It begins with raw energy. The transmissions from these sites are not the gentle whispers of a radio station. They are focused pulses of radio energy with a peak power measured in the millions of watts. To grasp this scale, consider a striking analogy. When the Arecibo dish was broadcasting its message, the effective power of its focused beam was roughly 20 trillion watts. For the brief instant of that transmission, that single signal contained more power than the entire electricity consumption of the human race at that moment in time. All the lights in every city, all the factories, all the homes, all of it was outshone by that one beam aimed at the stars. But raw power is useless if it is not focused. This is where the genius of these dishes comes into play. Their immense curved surfaces act like a cosmic magnifying glass, concentrating all that radio energy into an incredibly narrow beam. The Arecibo dish, for instance, could focus its signal into a beam only about 2 arc minutes wide. To understand that precision, imagine standing in New York and using a laser pointer to highlight a single grapefruit in Los Angeles. The beam from these radars is even tighter than that. This beam forming is the true secret. Without it, our signal would spread out in a useless, weakening sphere, becoming indistinguishable from the background static of the universe within just a few light years. By focusing it into a razor-thin spear of energy, we give the signal a fighting chance to travel dozens, hundreds, or even thousands of light years while still remaining strong enough to be picked out from the natural radio hiss of cosmic objects. This is the monumental engineering challenge behind every message. We are not just broadcasting, we are aiming a needle of concentrated energy across a cosmic ocean, hoping its point is sharp enough and bright enough to be seen by someone someday on the other side. Each transmission we send carries a different weight of consequence. To measure that weight, scientists created a tool known as the San Marino scale. Developed by METI researcher Ivan Olmer, this is not a physical instrument, but a conceptual framework designed to quantify the potential risk of any active message sent to the stars. It forces us to ask a critical question: just how loud and how revealing should our cosmic shout really be? The scale assesses risk based on 2 fundamental factors. The first is magnitude. This measures the raw power and persistence of the signal itself. A brief, weak transmission scores low, while a continuous, incredibly powerful broadcast, like a lighthouse beam that never turns off, scores very high. The second factor is character. This judges the information richness of the message. A simple, repetitive beacon of prime numbers has a low character score. It announces our presence without revealing much about who we are. But a message packed with our DNA sequence, detailed maps of our solar system, personal thoughts, and our music that has an extremely high character score. It offers a deep and revealing portrait of humanity. When you combine these 2 numbers, you get an overall risk assessment for a given transmission. Let us apply this scale to our real-world messages. The historic Arecibo message would score surprisingly low on the San Marino scale. Its magnitude was astronomical for that single 3-minute burst, but its duration was fleeting. Its character was significant for its time, but still a relatively simple scientific pictogram. It was a powerful flash, but a brief and somewhat cryptic one. Now consider the Lone Signal Project. Its ambition was to broadcast a continuous stream of messages. This would have given it a very high magnitude score over time. Its dual content, a scientific beacon interwoven with thousands of personal human thoughts, would have also earned it a high character score. Even though its individual signal strength was lower than Arecibo's, its persistent and deeply personal nature made it, by this scale's measure, a much riskier endeavor. This tool does not tell us whether an action is good or bad. Instead, it gives us a common language to debate the safety and responsibility of speaking for Earth. For those who advocate for METI, a low score on the San Marino scale can be used to argue that a proposed transmission is a cautious, calculated risk. For those who oppose these activities, a high score confirms their worst fears, that we are carelessly broadcasting our existence and our vulnerabilities to a universe we do not understand. The scale itself is neutral, a mirror reflecting the profound responsibility we hold every time we decide to break the silence. That responsibility feels terrifying when weighed against the silence of the cosmos. For every voice eager to shout hello, another warns we are courting catastrophe. The late, great Stephen Hawking was perhaps the most eloquent and respected proponent of this caution. He famously compared messaging alien civilizations to the encounter between Native Americans and Christopher Columbus. That meeting, he noted, did not turn out well for the natives. His stark warning echoes a core philosophical stance known as the precautionary principle. In its simplest form, this principle states that when an action has a potential for severe or irreversible harm, even in the face of scientific uncertainty, the burden of proof falls on those taking the action to show it is safe. It is the ultimate expression of better safe than sorry. Proponents of this view ask a chillingly simple question. Why would we assume that an alien intelligence capable of interstellar travel or communication would be benevolent? Our own history offers no comforting answers. Time and again on Earth, when a more technologically advanced society encountered a less advanced one, the results were invasion, exploitation, disease, and cultural eradication. The pattern is grimly consistent. The conquistadors and the Aztecs, European colonists and indigenous populations across the globe. In every case, the gap in technology led not to mutual enrichment but to subjugation. Why would the cosmos be any different? An alien species that could traverse the unimaginable distances between stars would possess technology so far beyond our own that we would be like ants trying to comprehend a human. Our greatest weapons, our most powerful computers, our entire global civilization might be seen as nothing more than a curious anthill, perhaps one worth studying, or worse, one worth clearing for a new interstellar highway. By broadcasting detailed information about our planet, its biological composition, and our technological capabilities, we are essentially handing a potential predator a complete dossier on our strengths and weaknesses. We are revealing the location of a planet rich in resources, including the most precious resource of all, biological life itself. The dark forest hypothesis, a concept popularized in science fiction, suggests a terrifying possibility. What if the universe is not silent because life is rare, but because it is hiding? In a dark forest, every hunter knows that to reveal your position is to become a target. The safest strategy for any civilization is to stay perfectly quiet, to listen but never to speak, for fear that any other hunter it encounters will shoot first. From this perspective, our METI efforts are not just naive, they are recklessly dangerous. We are the child in the dark forest, shouting and waving a flashlight, utterly unaware of what else moves in the shadows. The argument against METI is not born of a lack of curiosity, but from a deep sense of cosmic self-preservation. It asks us to consider that the greatest discovery in human history could also be our last, and that in our desperate search for companionship, we might instead be ringing a dinner bell. This profound silence from the cosmos might not be empty at all. It could be a deliberate, curated quiet. One of the most compelling answers to the famous Fermi paradox, the question of where everybody is known as the zoo hypothesis. Imagine our solar system as a vast protected wilderness area in a galactic national park. Advanced civilizations, the argument goes, are all around us. They know we are here, but they have chosen to place us under a form of cosmic quarantine, observing us from a distance to allow our culture and technology to develop without outside interference. They are the quiet visitors on the other side of the one-way glass, watching the curious creatures of Earth evolve on their own. In this scenario, our planet is a living museum, a preserve of biological and social novelty. The great silence we have been listening to for decades is not a sign of our loneliness, but a policy of non-interference on a galactic scale. This changes the entire meaning of our attempts to communicate. If the zoo hypothesis is correct, then every METI transmission is not a friendly hello, but an act of rebellion. We are not just tossing a bottle into the ocean, we are throwing rocks at the windows of the observation deck, demanding to be let out. We are trying to force a conversation that wiser, older beings have decided is not yet in our best interest. The question then becomes, what if we are not ready for contact? Human history is a chronicle of conflict, of societies colliding with disastrous results for the less technologically advanced. A more enlightened galactic community might have learned this lesson the hard way, establishing a strict prime directive to protect emerging civilizations like our own from cultural shock or exploitation. Our constant, increasingly detailed shouting could be seen as a violation of that protective protocol. It is the equivalent of a toddler who has just learned to talk screaming into a baby monitor, unaware that the parents are listening carefully, but waiting for the child to form a coherent thought before they respond. By broadcasting our location, our biology, and our technological achievements, we might be prematurely graduating ourselves from the protected nursery of the galaxy into a much more dangerous and competitive interstellar neighborhood. Are we, in our desperate search for companionship, accidentally announcing that we are open for business, or worse, that we are ready for a test we cannot possibly pass? The silent stars may be silent for a reason, and our shouts into the dark could be the one thing that breaks a peace that has protected us for millennia. This question of who gets to speak for our planet reveals a startling reality. There is no one in charge. Unlike the careful, internationally debated creation of the Voyager Golden Records, modern METI operates in a governance vacuum. The messages beamed from Arecibo and Evpatoria were decisions made by small teams of scientists and engineers. The cosmic calls from private companies and artists were funded by corporate sponsors or public donations. There exists no global framework, no United Nations committee, and no international treaty that regulates what we send into the galaxy or who gets to send it. This means that the voice representing all of humanity to the cosmos can be decided by the passions of a single researcher, the budget of a tech startup, or the artistic vision of a music festival. It is a system built on initiative rather than institution. The risk is not merely theoretical. Without coordination, we risk presenting a deeply fragmented and confusing picture of ourselves to any listener. One day, a distant civilization might receive our elegant mathematical descriptions of DNA from a scientific consortium. The next, they might intercept a stream of text messages dominated by internet memes and personal greetings. How would they reconcile these signals? Would they see a species of profound intellect and artistic depth, or a chaotic, adolescent culture unable to agree on a single message? The lack of a global conversation means we have no shared strategy, no agreed-upon first impression. This places an immense, unmanaged responsibility on the shoulders of a very few. The decision to represent Earth, a planet of nearly 8 billion unique individuals, should not rest on the availability of a radio telescope and a few $1,000s in crowdfunding. It is a decision that belongs to all of us, yet is currently made by almost none of us. Yet a chorus of powerful voices argues that this caution is a cage of our own making. For pioneers like the late Alexander Zaitsev, who physically sent many of our most famous messages, and psychologist Douglas Vakoch, the president of METI International, the silence is not a warning but a challenge to be broken. They see messaging not as a risk but as the next logical step for a species coming of age. Their argument begins with a simple, pragmatic observation. The idea that we are hiding is an illusion, a fantasy of quiet. For nearly a century, our planet has been screaming its presence into space. Every television broadcast, every radar pulse from air traffic control, every military transmission has been leaking into the cosmos, creating an expanding bubble of radio noise that has already washed over thousands of nearby stars. I Love Lucy and the evening news have been traveling outward at the speed of light since the 1950s. Any civilization with technology just a few decades more advanced than our own would have no trouble detecting this chaotic static and pinpointing its source to a small, rocky world in the inner solar system. From this perspective, a deliberate, powerful message is not a dangerous reveal. It is a polite and formal introduction. It is the difference between a neighbor overhearing you argue through the walls and you walking over, knocking on their door and saying hello. It shows that we are aware, that we are intentional, and that we wish to communicate with purpose, not by accident. But this is more than just a matter of cosmic etiquette. Advocates believe that making contact is a necessary part of our long-term survival. The challenges facing humanity, from climate change to potential asteroid impacts, are immense. The knowledge we could gain from a civilization thousands or millions of years older than our own could be the key to overcoming them. They might share the principles of physics we have not yet discovered, the solutions to diseases that have plagued us for centuries, or the technologies needed to become a truly multi-planetary species. This is not just about getting answers to our scientific questions. It is about accessing a cosmic library of knowledge that could ensure the continuation of our species. The potential rewards are not merely practical, they are existential. To find another intelligence would fundamentally change our understanding of our place in the universe. It would end our cosmic loneliness and give us a partner or perhaps a mentor in the great adventure of existence. The risks, they argue, are based on a deeply cynical view of evolution and intelligence, one shaped by our own violent history. Why assume that a species capable of the cooperation and long-term thinking required for interstellar travel would be inherently hostile? Perhaps the greatest filter to becoming a spacefaring civilization is overcoming the internal demons of war and self-destruction. Those who make it through might be the ones who learn to be peaceful, to be curious, and to be stewards of life, not its destroyers. By choosing to remain silent, we are not playing it safe. We are admitting a profound lack of faith in our own future and in the potential for a benevolent cosmos. We are choosing to sit alone in a dark room, afraid of what might be outside the door, while the possibility of enlightenment, friendship, and salvation waits patiently in the starlight. That haunting them in melody beamed toward the stars was far from an isolated event. The artistic community has steadily tuned its instruments to join the cosmic chorus, recognizing that a message composed solely of scientific data is like a skeleton without a soul. While the teen-age message pioneered the transmission of music and the Sonar project elevated it, other initiatives have since explored the very boundaries of interstellar art. One profound example is the Interstellar Music Project, a collective of composers and scientists dedicated to creating and transmitting musical works specifically designed for an alien audience. Their compositions are not simply pop songs converted into radio waves. They are built from the ground up using universal principles of mathematics and harmony. They explore concepts like the Fibonacci sequence in their rhythmic structures or the harmonic series in their melodies, weaving the language of the cosmos directly into the fabric of the music itself. This is not entertainment, it is an argument, a demonstration that the same mathematical order governing spiral galaxies also resonates in human creativity. So why is this considered so vital? A DNA sequence can tell another civilization what we are made of, but it cannot convey what it feels like to be human. Science describes the machinery of a sunset, listing the wavelengths of light and the scattering of particles in the atmosphere. Art transmits the awe, the tranquility, the bittersweet longing that a sunset can inspire. It communicates the emotional and aesthetic dimensions of our existence, aspects that are just as real as our chemical composition. In a universe of potentially unimaginable biologies, where senses and modes of thought could be utterly foreign, a shared reaction to a beautiful mathematical pattern or a harmonious sound might be one of the only bridges available. A complex, rhythmic piece of music could signal our understanding of time and pattern. A painting encoded into a signal, with its use of symmetry and contrast, could reveal our perception of balance and form. These are not human inventions in the way a specific language is. They are explorations of universal constants that any advanced, sentient mind might also perceive and appreciate. Art becomes our offering, our way of saying that we do not just inhabit the universe, we experience it. We find it beautiful, we find it terrifying, and we are driven to create echoes of that experience. When we send our music and our art into the void, we are attempting to share the one thing that pure data can never contain, the inner light of consciousness itself. Our messages are deliberate shouts in a much wider, quieter search. This grand endeavor to find life beyond Earth is split into two distinct paths, listening for whispers and looking for footprints. On one hand, scientists hunt for biosignatures, which are signs of any life, even the simplest microbes. Imagine a telescope analyzing the light passing through a distant planet's atmosphere. If it detects certain gases like oxygen or methane in unnatural combinations, gases that should quickly react and disappear unless something is constantly replenishing them, that could be the chemical signature of a living world. It is evidence of a biological process, a hint that something, even if just single-celled, is breathing and altering its environment. The other path is the search for technosignatures. These are the traces not of life itself, but of technology, the marks of an intelligent tool using civilization. This could be the radio leakage from a planet, the unnatural glow of city lights on its night side, or even massive structures orbiting a star designed to capture its energy. Messaging extraterrestrial intelligence, our active calls, are the most extreme form of this second path. We are not just hoping to spot a distant city light, we are building a lighthouse and aiming its beam directly at the neighborhood. While METI actively seeks a conversation, most of astrobiology is a patient, passive search for these faint signatures, and our ability to conduct that search is undergoing a revolution. Telescopes like the James Webb Space Telescope are already peering into the atmospheres of distant worlds, analyzing their chemical compositions for those telltale biosignatures with a sensitivity that was pure science fiction just a generation ago. The future holds even more promise with projects like the Habitable Worlds Observatory, a planned space telescope designed with the explicit goal of directly imaging Earth-like planets around other stars and searching for signs of life. This incredible progress makes the context for METI more relevant than ever. As we get better and better at finding potential homes for life, the question becomes more urgent. If we one day point a telescope at a world glowing with the chemical signs of a global biosphere, or even shimmering with the artificial lights of cities, what will be our next move? Will we simply continue to observe from a safe distance, or will we feel compelled to finally answer the silence with a deliberate, powerful hello? Our cosmic calls are rehearsing for that very moment, preparing a voice for a planet that may soon have someone to talk to. The driving force behind so many of our cosmic calls was a man who believed silence was not an option. Dr. Alexander Zaitsev, a Russian radio astronomer from the Institute of Radio Engineering and Electronics, was not just a researcher, he was METI's chief evangelist. His career was defined by a singular, unwavering conviction that humanity's greatest achievement would be to start a conversation with the stars. Zaitsev was the mastermind and chief operator for the transmissions that gave this philosophy a voice. He personally oversaw the technical execution of projects like Cosmic Call and the Teen Age Message, using the powerful Evpatoria radar in Ukraine as his cosmic megaphone. For him, these were not mere experiments, they were the first earnest attempts at interstellar dialogue, messages crafted with the explicit hope of a reply. His philosophical stance was elegantly simple, and he repeated it like a mantra. If you want to get an answer, you asked a question. To Zaitsev, the decades of passive listening under SETI were like sitting by a silent telephone hoping it would ring. He argued that we had to be the ones to dial a number, to take the active step of initiating contact. He saw this not as recklessness, but as the natural maturation of a technological species, a declaration that we were ready to join a wider community. This belief put him at direct odds with scientific giants like Stephen Hawking. Where Hawking saw existential risk, Zaitsev saw cosmic opportunity. He countered the dark forest fears by arguing that any civilization capable of interstellar travel would have necessarily overcome its own self-destructive tendencies, that survival on such a scale demanded cooperation and wisdom, not predation. He believed that the potential knowledge to be gained, the solutions to our own planetary crises, the sheer philosophical uplift of knowing we are not alone, far outweighed the hypothetical dangers. His legacy today is as polarized as the debate he championed. To his supporters, Alexander Zaitsev was a visionary, a pioneer who had the courage to act on humanity's deepest yearning for connection. He is remembered as the man who gave our music and our personal messages a ride to the stars. To his detractors, he was a maverick who unilaterally decided humanity's fate, a man whose profound optimism potentially put our entire species in jeopardy. Yet, regardless of which side you take, his impact is undeniable. Every discussion about the ethics of messaging extraterrestrial intelligence, every new project that aims to send a signal, is happening in the shadow of the questions Zaitsev so passionately insisted we ask. He transformed METI from a theoretical idea into a series of real, powerful transmissions now traveling through space, each one a testament to his belief that the universe is waiting for us to speak first. That philosophical optimism needed a permanent home, a place where the desire to speak to the cosmos could be studied with scientific rigor. This institutional push found its voice in METI International, a non-profit research organization founded by psychologist Douglas Vakoch. While pioneers like Alexander Zaitsev were brilliant soloists, METI International aims to be the entire orchestra, bringing structure, collaboration, and deep ethical consideration to a field often driven by individual passion. The organization's very name is a declaration of its mission, embracing the active nature of messaging extraterrestrial intelligence as a legitimate scientific discipline, not just a fringe activity. At its core, METI International is dedicated to two interconnected goals: transmitting intentional, powerful signals to other stars, and thoroughly researching the profound social and ethical implications of doing so. This dual focus is what sets it apart. They are not just building a cosmic megaphone, they are also building the framework for the global conversation we should have before we use it. Their research delves into the toughest questions. How do we create a message that is truly universal? What are the long-term risks and how can we mitigate them? And perhaps most importantly, how do we develop a sense of astrobiology ethics, a set of principles to guide our actions as we reach out to potential life? This work involves not only astronomers and engineers, but also linguists, artists, sociologists, and philosophers, creating a holistic approach to the biggest question humanity has ever faced. Beyond the theoretical, METI International is actively planning for the future of transmission. They are developing sophisticated new message protocols, far more advanced than the simple binary of the past, designed to convey complex concepts about human culture and consciousness. They are also strategizing the next generation of transmission targets, looking beyond nearby stars to systems with the highest potential for habitability. By serving as a central hub for scientists and advocates worldwide, the organization is working to transform METI from a series of isolated events into a sustained, thoughtful, and globally aware endeavor. They are the steady hand trying to guide our cosmic shouts, ensuring that when we speak for Earth, we do so with wisdom, clarity, and a full understanding of the incredible responsibility we hold. The next wave of cosmic messages may not even be written by us. Imagine an artificial intelligence trained on every book, every song, and every scientific discovery our civilization has ever produced, composing a greeting to the stars. This is not science fiction, but a serious proposal for the future of METI. An AI could generate a message of unimaginable complexity and nuance, weaving together our mathematics, our art, and our philosophies into a seamless tapestry. It might even encode the very patterns of human consciousness, translating the electrical symphony of a living brain into a format another mind could potentially interpret. The most intimate message we could ever send might be a digital echo of thought itself, a shared dream beamed across the light years. Others have suggested transmitting the complete human genome, a literal blueprint of our biology. This would be the ultimate act of cosmic trust, handing over the instructions for building a human being to an intelligence we cannot possibly comprehend. The question shifts from what we should say to how much of ourselves we are willing to reveal. To carry these profound new messages, we will need a voice of unprecedented power. That voice may soon belong to the Square Kilometre Array. When this next-generation radio telescope network is completed, it will not only be the most sensitive listening device ever built, it could also become the most powerful transmitter in human history. Its thousands of dishes spread across 2 continents could be synchronized to form a single, colossal beam. A signal sent from the SK would be like a cosmic spotlight, so intense and focused that it would outshine our previous transmissions by orders of magnitude. It could project our most complex AI-generated messages across the galaxy with a clarity that would be unmistakably artificial. But the ultimate ambition goes beyond just sending a louder message. Future strategies might involve creating an interstellar dialogue, not a monologue. One radical idea is to send a repeater. This would not just be a message, but a package containing the very tools needed to understand it and craft a reply. Think of it as a universal translator and a return envelope all in one. We would transmit the architectural plans for a simple receiver and transmitter, along with a primer on our language and science. A receiving civilization could theoretically build this device, comprehend our message, and use the provided tools to send a response back to us, effectively handing them the keys to a two-way conversation. This transforms the act of messaging from a hopeful shout into the foundation of a bridge, one we are building from our end with the faith that someone someday will choose to build their half to meet us. So we arrive at the ultimate question, the one that lies at the heart of every transmission. If a global committee was formed tomorrow with the task of creating a single, definitive message from Earth, what would we actually say? This is not a technical challenge, but a philosophical one that cuts to the very core of our identity. Do we present an idealized version of ourselves, a polished highlight reel for the galaxy? Or do we embrace a brutal, unflinching honesty, sending the full, complicated truth of the human condition? Imagine crafting a digital time capsule that must represent 8 billion individuals, thousands of cultures, and the entire sweep of our history. Where would you even begin? One school of thought argues we should send only our greatest triumphs. We would beam the timeless beauty of a Bach fugue, the elegant logic of Einstein's equations, and the profound questions posed by Shakespeare. We would share images of the Sistine Chapel ceiling and the Great Pyramid of Giza. This message would present humanity as a species of creators and thinkers, emphasizing our potential for wonder, discovery, and sublime artistry. It is a vision of us at our very best, a species worthy of conversation. But this curated portrait feels incomplete, even dishonest. It airbrushes out the shadows. A different perspective insists that true representation requires acknowledging our flaws. Should we include the schematics of a nuclear bomb alongside the double helix of DNA? Do we send footage of a thriving coral reef followed by images of a clear-cut forest? Do we document our capacity for selfless love and then detail the history of our countless wars? This approach argues that to hide our destructive side is to present a false face. An advanced civilization would likely see through the facade anyway, and our willingness to be transparent about our struggles could be the most powerful signal of our maturity. It says we are self-aware, we recognize our problems, and we are a work in progress. This is the immense weight of speaking for a planet. Every choice in the message is a value judgment. Highlighting our scientific knowledge might suggest we are a logical, rational species. Prioritizing our art and music implies we value beauty and emotion above all else. Focusing on our peaceful intentions could be seen as either a noble aspiration or a sign of profound vulnerability. There is no neutral message. The very act of selection defines who we think we are and, more terrifyingly, who we aspire to be. This global committee would not just be drafting a greeting, it would be attempting to write a definition for humanity itself, a single statement to be read against the backdrop of a silent and waiting universe. Our journey across the stars has been a story of increasing ambition and profound self-reflection. We began with a single shout of pure science from Arecibo, a 3-minute burst of binary code describing our DNA and our mathematics. From there, our messages evolved into something more personal, more human. We sent the collective dreams of thousands in the cosmic call, the youthful artistry of the teen-age message, and finally, the abstract soul of our music from sonar. Each transmission is a layer in a self-portrait we are painting for the cosmos, a portrait that grows more detailed and more intimate with every passing decade. Yet this entire endeavor is balanced on a razor's edge, pulled in two opposing directions by powerful human instincts. On one side stands the unshakable optimism of pioneers like Alexander Zaitsev, who see a universe ripe for conversation, a place where sharing our knowledge and our art is the key to our own survival and growth. They believe our greatest achievement is reaching out, forging a bond that would end our cosmic loneliness forever. Arrayed against them are the cautious warnings of thinkers like Stephen Hawking, who see a dark forest where revealing our location is an invitation for catastrophe. They counsel patience, arguing that a species that shouts into the unknown without understanding the potential consequences is gambling with its very existence. This is the central, unresolved conflict of our time. So where does that leave us? Is messaging extraterrestrial intelligence humanity's ultimate act of hopeful bravery, a declaration that we are ready to join a galactic community? Or is it our most naive and dangerous mistake, a foolish risk that could one day invite a threat we cannot possibly comprehend? The signals are already on their way, carrying our choices into the future. There is no turning back now. We want to know what you think. Do you believe we should keep shouting, or should we embrace the silence? Share your thoughts in the comments below. And if you have enjoyed this deep dive into our future among the stars, please subscribe for more. And tonight, when you look up at the sky, remember to wonder not just if someone is out there, but what you would want to say to them if they were.